So for one, there's constant and continuous environmental change. So there's fluctuations seasonally, daily, yearly. You might have a storm come through that you weren't expecting, some sort of natural disaster. There's also human environmental change where landscape that used to be open space is now developed land. There's a brand new road that goes through. There might be pollution, noise, sound, and air pollution. So there's continual environmental change. And some of this change happens at a rate that's difficult for flora and fauna to adapt to. And so we're seeing this unprecedented loss in biodiversity globally. But it'd be one thing if the change was, happened one time in one place in a vacuum, and it was a really simple, easy fix. But of course, these systems are incredibly complex, and there's multiple changes happening at once with varying levels of intensity and severity and frequency. So there's really, really complex systems with constant change and a lot of uncertainty. So even if you think you understand what's going on with an ecosystem, all of a sudden something surprising happens, like a new invasive species comes in. So there's constant change and uncertainty in these systems. And so that's kind of a challenge in trying to maintain these ecosystems. In the same vein, though, there's something that are working in our favor as well. So as we continue to advance our research, we have these scientific advancements. So our equipment gets better, our methods and our protocols get better. So we more efficiently and effectively are able to manage and maintain these ecosystems. And in the same vein, we're also collaborating and sharing our data with our regional and global partners. And there's been a big push to do that recently, and we're continuing to do so. And all of that increased collaboration adds to the efficiency and improvements that go into our projects. But the really big question is, how do we even start? How do we decide how to make decisions in a world that is constantly changing and so complex and so uncertain? And one of those tools that we can use is a framework called adaptive management. It's a flexible decision-making process that can be adjusted in the face of uncertainties as outcomes of management actions, as well as other environmental changes, become better understood. And so if we carefully monitor those outcomes, it advances both scientific understanding and helps us adjust policies and protocols and practices when it comes to our management decisions. It's this iterative learning process. You learn by doing. So the more you do and learn, you do better, kind of an idea. So you're simultaneously managing as well as learning about the natural resources at the same time. And that concept within a framework looks a little bit like this. This is the adaptive management framework. It's kind of a life cycle of a research project. So you start with assessing the problem that you have. So maybe you have a new invasive species, or there might be some population declines or some degraded lands. You're starting with some sort of a problem. You design and implement a project in order to address that problem. You monitor the changes after you've implemented that management decision or that study design. You evaluate the results, and then based on those results, you might adjust your practices, you might adjust your management of the land or the species group, or you might find that you have a completely new problem that you need to address and you start the cycle over again. So it's just this continual learning, continual doing. And I think, sorry, I'm getting some feedback. All right, I think we're good. Okay, so I've taken this diagram and I've adjusted it for the preserve, and it looks a little bit like this. Melanie showed it on the slide beforehand. So we start off with our flora and fauna surveys. We don't know how to maintain our ecosystem unless we know what's here, right? So we have our flora and fauna surveys, what's here, what's going on, assessing the situation. And then based on what we find, we can have specific research goals based on maybe there's a focal species, a sensitive species, or a species group. It might be a group of bioindicators that are indicating the health of an ecosystem. It might be a targeted question. So what's the best way to restore land? And then we implement that study, monitor, and based on those results, we might do a couple different things. So we might have a different question like the diagram before. We might notice there's something we can do about it. So we have a management action, we monitor the results based on that, or we might just continue to monitor like our long-term monitoring projects until we have a result that goes, hey, we should implement this management decision, and then we'll move to the management action. So it's this kind of continuous flow, life cycle of these projects to constantly be improving our projects and improving our management of these lands. So I'm going to talk about this concept with an example of a project we have in the preserve, and that would be the bat project. So for our bat project, originally we found this old mine where there was bats roosting in it, and we wanted to know which bats are roosting in it. Are they using it as a maternity colony or just regular roost? And particularly, is it a Townsend's big-eared bat roost, which is a sensitive species that resides in the preserve? And if so, it would be really important to protect this roost, and also be very interesting because these bats are not only sensitive to human disturbance, but they're also roost specialists. So they have very particular requirements for the roost that they use. It's really rare to find one. So if we did find one, it would be really incredible opportunity to study these bats. So we conducted an experiment to first determine, are there Townsend's big-eared bats using this roost? And if so, how are they using it? What time of year? How active are they? Just all those kind of questions. What conditions are going on in this mine? And so to conduct this experimental study, we did some captures annually from 2016 to 2019. In 2019, we confirmed that the roost was being used by Townsend's big-eared bats, and started our 3-year experimental study of emergence counts using video recording. So up at the top right here is our HARP track, where we capture the bats coming out of the mine. And on the bottom right here is our video recording. You can see there's a bat flying out of the mine gate there. And that's to get an idea of the activity going on at the mine. We did that from 2019 to 2022. So what did we find? Well, first thing, we confirmed that the old mine is an active maternity roost for Townsend big-eared bats, which is very exciting. Our last capture we did in 2022, we found 41 lactating or pregnant female Townsend big-eared bats. So it's a very, very active maternity roost. So it's something we definitely want to be monitoring and protecting. Then we also observed, using the emergence counts, that bats were exiting the mine during most months, though they were least active in the winter and most active during March through May. And then preliminary data shows that bats emerge less when temperatures are super high or low. And we also found that there's a bit of a threshold you can see at this chart at the top right here, where in the active seasons, bats are around 20 or more bats is what we consider bats being active. And that's in that March through May category. And then the question is, what do we do now that we have this baseline information about our bats? Well, we transitioned to more of a long-term monitoring project. So we really want to monitor this population for any sort of declines. And we're also really interested to see if this colony is affected by white nose syndrome. It hasn't reached the area yet, but it's something we're looking out for. And so what we'd like to do is proactively manage and monitor this colony of sensitive bats. And to do so, we're going to develop an adaptive management plan. And it looks a little something like this. So this adaptive management plan was developed in collaboration with our partners, so Field Institute staff and our research partner, Dr. Marianne Moore, as well as some Game and Fish folks as well, and Debbie Langenfeld, who you'll hear from later, who's the lead of this project and citizen science lead. And the idea was to take all of the information we gathered with our experimental study plus the scientific research and have some sort of thresholds that will trigger management actions and also account for uncertainty, right? Up at the top here, this is just a timeline throughout the year. And the idea is that we start in January, start our emergence counts, we're recording the bat activity. Then once we hit 20 bats, that's our threshold we've decided is our bat activity, we will conduct a capture to check for white nose syndrome. The reason we want to do that is the closer you are to winter, the easier it is to find white nose syndrome on the bat species. So once we hit that 20, that's our trigger to go ahead and capture bats and check for white nose syndrome. Then we'll continue those emergence counts through the active season, March through May, and then stop the counts when the bats are observed less than 20 observations are observed 2 months in a row. And the reason we do that is we're accounting for the idea that just because March through May was the active season for the bats the last 3 years doesn't mean it always will. If temperatures are changing, if conditions are changing, they might arrive earlier or later or leave earlier or later. And we want to make sure we're accounting for that and not missing out on important data. And then based on what happens at these touch points along the way in this plan, we have set aside what we would do in the case of WNS not being detected or WNS being detected, right? So if it's not detected, we're not really worried about the disease on these bats. But if it is detected, we report it and we launch our plan for white nose syndrome, which is you don't want to track that around to all the other bats, right? So that's kind of the idea of this adaptive management plan, is having really, really clear thresholds along the way and very clear measurements of when you want to act. And the reason this is so important is because when you're dealing with a sensitive species like this, right, you don't want to wait 10 years before you take action if the population is declining, right? So, you want to be taking action and seeing if that action actually works to help that species, and based on that, learning and adapting along the way. So it's this way to really keep your finger on the pulse of what's happening, especially particularly with species that are sensitive or invasive species, things like that. And so then just to round out this frame of reference that we're doing with the BAT project and how that fits back into that graphic that we were talking about. We started out with that flora and fauna survey. The bats are there. It's a sensitive species. We're really concerned about it. So we have this experimental study where we're monitoring the population, seeing when it's active, and conducting that research. And then based on the results, we now have these thresholds, this plan, and what we can do about it if these bats decline or we find white nose syndrome. And right now we're in that long-term monitoring section where we are just going to see what happens year to year, long-term monitoring based on those results. And unless we reach one of those thresholds, we'll just keep monitoring. And then if we reach a threshold of, oh, this population is declining, or we've detected white nose syndrome, then we implement a management action and monitor from there. So that's kind of the general life cycle of the BAT project currently. And then you can apply that concept to all the other research projects that we do in the preserve, just with a few considerations. So having really clear and relevant thresholds, of course, what's good for bats might not be good for bobcats, and so forth. So you have those really clear, relevant thresholds that you tweak as time goes on. You account for that uncertainty. So in the same way that we monitor well on either side of the active season for the bats, you might do something similar for a project that you're looking at to account for changes in the environment year to year and unexpectedly. And really kind of radically accept this iterative learning process. So the more you know, the better you will do in the future, and leaving room for changes and improvements as we go on. Having those super measurable management actions. So because we're monitoring the population before we implement a management action and after, we can actually see if there are changes. So that's really important when managing an ecosystem. And then of course, collaboration. So your adaptive management projects are strengthened by the amount of partners that you have and information that you're sharing, because everything that they're learning, they can share with you and you with them. And that also adds to that iterative learning process along the way. So we want to make sure we're having data that's comparable and shareable, and that we're always implementing our data into regional databases and working with the people in the region and beyond. And this concept can go through all the different types of research that we're conducting currently in the preserve, our long-term monitoring, our experimental research, and our management-driven research, which you will hear about coming up here soon. Okay, so like they mentioned, my name is Jessie Dwyer. I'm the biodiversity manager at the Conservancy, and today I'll be talking about adaptive management, that framework, and how we incorporate that into the research we do in the Field Institute. And the overarching goal, one of the overarching goals of the Field Institute is to maintain a healthy ecosystem into the future, protect our natural resources and maintain biodiversity. However, there's many challenges that we face in trying to realize that goal.
Jessie, what can you name a couple of benefits of a healthy bat population?
Yes, absolutely. So bats are very, very important for the ecosystem. A lot of the bats that we have in Arizona are insectivorous bats. So they're kind of like a natural pest control. So they take down all the insects at night. So that's really important. Bats can also be pollinators. So we have saguaros here, which is a plant that bats will pollinate. And then they're also kind of just... yeah, they have sorry. And there's a bat called the pallid bat, which is one of my favorite bats. It eats scorpions. So if you're not a fan of scorpions, sorry to throw scorpions under the bus. They're really good at that. And they also are really bad at getting nectar out of cacti because they are not nectarivorous bats, but they're really messy. So they actually pollinate really well. So that's a fun desert bat that's really good for the ecosystem.
Awesome. Thank you. We have one more. Is white nose syndrome found in nearby states?
Yes, it is. It is encroaching around us as we speak. And it's one of those things that we're really trying to be proactive about it, because it's potentially a matter of time before it comes here. Now, white nose syndrome is best in cold and damp environments, but that doesn't mean it will always be that way. That doesn't mean there's not that cave conditions here. It also depends on the bats that get affected. If they roost really close together, it might be more affected than bats that are more solitary. But one thing is that, one of the reasons why we're checking on the Townsend's big-eared bat, we're not sure exactly how this bat is going to respond to white nose syndrome, but if it's in the area, that indicates it might be affecting other bat populations in the area as well. So since we have this roost, we want to monitor that.
Great, thank you.
Yeah.
We have one last question. I'll answer the others separately, but can bats transmit white nose syndrome to humans?
No, it's a bat-to-bat transformation. So the disease will be on our gear, and the way that it was actually transferred was humans bringing European pathogens into the US. So the one thing we're really worried about is humans passing around the pathogen to the bats, but it's a bat-specific pathogen, so it's not a human-to-bat disease.
Okay. Thank you. I think that concludes the questions. Thanks, Jesse. This is time for folks to ask any questions. We probably have time for 1 to 2 questions in the chat function.